morning, students. Welcome back to RB online class. So today we are in 9th class. That is, we were seeing last class about the third chapter. That is the atoms and molecules. So we started in the last class this chapter, and the further topic in this class or in today's class is like what is this atomic mass? Then I had said like after the discovery of this tiny particle which was named as an atom, then the question arises what should be the mass of this atom or how to measure mass of the atom. So either then what should be the unit was the question. How to measure what should be its unit? Either it should be as that of we use some standard SI kg, then meters, centimeters. So you'll be using this. But if you take this atomic mass or an atom, then you could see that this atom is very tiny particle. So if we go on measuring with the unit as a kg, then if you see an atom and if you try to compare that with the atom, the kg unit, you could see that atom is very small and that unit would be very big. So they invented or they gave the one standard unit which is called atomic mass unit, or which is written as symbolically it is written as AMU, and or you can write it as a unified mass which is given the symbol of U. So this was an atomic mass unit, or you could say it as a unified mass, which was one of the standard measurement for measuring the mass of an atom. Then how to measure or what would be the measure or what would be the equivalent was the question. Then you would see that 1 U or 1 AMU would be equal to 1.67 into 10 raised to minus 27 kg. So if you try to compare 1 U or 1 AMU with kg as one unit, then it would be almost equivalent to 1.67 into 10 raised to minus 27 kg. That means what is 1 kg equivalent to 1 unit you might have got now. So this will be approximately equal to mass of a proton or neutron. So not exactly the same, but almost or approximately this 1 kg is always equal to a proton or a neutron mass. So this was one of the unit which was used to measure. So what happened is when they go on calculating the atomic mass of each element in the periodic table. So what happened? They took line by line like hydrogen, then they took helium. So what they found is when we try to compare one element with the other such that we get some relationship. When they went, or if we take an hydrogen which has an atomic mass of 1, so what happened is if you try to take this and try to measure the mass of other atom, then we would come to an end where the other atoms mass would always come in the points. So again there was some difficulty to easily get to know what is this atomic mass or what equivalent was to be done such that we get the whole numbers. Then what they got is they got the isotope of the carbon, that is carbon 12. Carbon 12 is an isotope of the carbon. So what is this isotope, you all know? So carbon doesn't exist only in one form. It has different isotopes, or it has different forms. So when you take this carbon 12, what happened? Carbon 12 isotope, and they kept this as a reference and they took the measurements taking this as a reference, other elements they found out the atomic mass. Then what happened is they approximately all the atomic masses were coming in the whole numbers. So what happened, this carbon 12 isotope they took as a standard reference for the measurement of the AMU, and they calculated the atomic mass of all the elements in the periodic table. So what they did is like consider this as a carbon atom. So if you take this as a carbon atom, or imagine that this is some fruit, or consider this as a watermelon. So what they did is they first tried to divide this into 12 equal parts. So they divided this whole into 12 equal parts. That carbon atom, or if you take a watermelon, so this 12 equal parts they divided. Then they said like, if you take this as one unit, like if you take this as a one unit, then they said this mass, whatever is there, that is equivalent to 1 U. So this one unit, so I will draw here, this 1 unit is equivalent to 1 U, or 1 AMU. So this is how they found the atomic mass. So what they did is, the 1 AMU is equal to 1/12 of the carbon 12 atom, or carbon 12 isotope. They said like 1 AMU is equal to 1/12, since there are 12 equal parts. So 1/12 of that carbon atom 12 isotope is equal to 1 AMU. So they found out on this the atomic mass of all the atoms. So this was about the atomic mass. So I hope this is clear for you all. So that like 1/12 of this carbon 12 is equal to 1 AMU. So I hope this topic is clear, like what is this atomic mass. Then we'll study about the Then we will study about the molecule. Now we have studied about the atom. So next would be the molecule. So what is this molecule? So it is defined as the smallest, like whatever the atoms, many atoms, they combine together to form the molecules. And molecules, they try to combine together and they form a compound. So I'll define what is this molecule. So it can be defined as the smallest particle of an element. So it could be an element. So their question comes how this could be an element or it could be a compound. So I'll explain how that could be an element that is capable of independent existence and shows all the properties of that substance. So it can be defined as the smallest particle. Obviously, it is like particle means atoms. So those atoms may be either 2, 3, or sometimes it may be more atoms. So those combined together, they form the molecule, which has the capability to show all the properties of the substance, and they can exist independently. So I have said here as the smallest particle of an element or a compound. So example, if you take an element, then you can say that H2 is the element. So hydrogen, so you know that this hydrogen is a diatomic. So it has 2 atoms. So it has 2 atoms, but one atom, one hydrogen atom is unstable. So it always forms as H2. So we write it as H2. So this would be an example of one molecule that is an element. So now if you take an example of water, so it can be like H2. So if you take this, then you would see that one tumbler of, or one glass of water which has H2O. So many of that H2O molecule, they combine when we call it as a water, or they exist independently, and all the molecules which are there in this water have the same chemical properties, or they show all the chemical properties that water should have. So whatever the chemical properties the water should have, so these molecules, they show all the chemical properties of that molecule. So I hope this is clear, like what is the molecule. Now next you can see that molecule is either a group of 2 or more atoms that are chemically together bonded, and they are tightly bonded with some attracting forces. So example, if you take like molecules, you can see that it may have two or more atoms that are chemically bonded, like they are chemically bonded together with the help of some attractive forces. So example, if you take as H2O, there is some, if you take this molecule as an example, there is some attractive force between the hydrogen and oxygen, such that there is a formation of the molecule water. Or if you take example of HCl, then you could see that there are some attractive forces by which they are chemically bonded or they are strongly bounded, such that they form the molecule. So here if you took two atoms, so sometimes it could be three, if you take like it could be also four sometimes. So two or more atoms, they are bonded chemically strong by some of the attractive forces. Then you could see that molecules of an element are constituted by the same type of the atom. So even if molecule can be considered if it has the same type of atoms, same type of atoms in an element. Like if you take an hydrogen, you could see that there are two same atoms that are combined together to form the molecule. So this also atoms of that element can also be called as the molecule. So this molecule, whatever it is there, it is called as diatomic, since it has two molecules, that is one hydrogen, two atoms, so it has diatomic. So if you take an example of an helium which is stable as one atom, so it is called as the monoatomic. So this is called as monoatomic. Then you can see that the number of atoms constituting in a molecule is known as atomicity. So you can see that the number of atoms that are present in the molecule, that property or that is called as atomicity. So we'll see with an example. So if you take an example of a sulfur. So sulfur, which has the atomicity of 8. So it has the 8 atoms in sulfur. Then if you take a phosphorus, which has the atomicity of 4. So this says that the atoms that are present in this phosphorus molecule is 4. So the number of atoms constituting in a molecule is called as atomicity. So if you take H2, then the atomicity would be 2. Then if you take oxygen, it would be 2. Then if you take ozone, so you might have known what is this ozone. So if you take ozone, which has a formula of O3, the atomicity would be 3. So this ozone, you know that, which helps in not allowing the ultraviolet rays or harmful rays getting into the earth from which are getting from sun. That this ozone layer protects us from those harmful ultraviolet rays which are coming from the sun. So that has the atomicity of the 3. So I hope this is clear for you all. So the number of atoms constituting in a molecule is known as its atomicity. Next, we have molecules of that compound. So what is that? So I hope what is this atomic mass, then what is this molecular mass or molecule, it is clear for you all. Then we have this atoms of different elements, they join together in definite proportions to form the molecules of that compound. So you can see the examples which is given in your textbook, that is page number 36, table 3.4. So if you take an example of a compound, so water. So water is a compound which has a formula of H2O. So what are the different elements or combining elements in water is the hydrogen and oxygen. So by they have the definite proportion, so that is called as the molecules of the compounds. Atoms of different elements, they join together in definite proportion such that they form the molecules of that compound. Then if you take an example, carbon dioxide, so which has the formula of CO2. So here what happens? We have carbon dioxide, that is carbon, then we have oxygen. So these two, they try to combine in definite these two atoms of elements. So carbon is one element, oxygen is one different element. So these, they try to combine and they form the compounds of the molecule. So when they are joined, then we say that it is the compounds of the molecule. Same way if you take ammonia, that is ammonia, it has NH4. So if you take, then it has nitrogen and hydrogen. So these two, they combine in definite proportion. So that proportion would be like 14:3. So this will be fixed, whatever the proportions they run. So 1:8. So in last class also I have written this ratio. So they will be trying to combine. So elements of atoms of that element, they combine together such that they are constituting the molecule of that compound. So this is the molecules of that compound. Next we have the topic called as ions. So we have studied till now about atoms, that is tiny particles. Then we said molecules, that is many different two or more atoms. They try to combine and they form the molecule. Now we'll see what is this ions. So now we'll see what is this ion. So ion is something like the charged particle. So what is this ion? So compounds that are composed of metals and non-metals contain a charged species. So these charges are called as the ions. So if you take an example of if you take an AOH, then you take HCl. No, not HCl. If you take any of them, so which has the like H2SO4, it should have the this also will not come. So if you take an example of NaOH, so if you see that it has the metal and the non-metal. So in that, so for example, if you take atom, so if you take an atom, say that atom A. So imagine that this is atom A. So whenever you know that these atoms are bounded or they have the electrons in them. So they have these electrons in them. So either they donate the atom, or what happens if imagine that this is atom A or atom B, or they either receive it. So they either donate it or they either receive it. So these two are some examples, like this is atom A and atom B. So where if you take like one atom, either it donates or sometimes it also receives. So if you take an atom which tries to donate such that it attains its stability, then you can see that before it donates, any atom which is present, it is neutral. That is, it has equal number of electrons, protons or neutrons in it. So we say that it is neutral atom. But in a periodic table, if you take many elements, then you could see that there are many elements which react and they try to form the compound. So if you take any element, if it, for example, it donates the electron such that it becomes like it donates one negative, then what happens is it becomes the if it donates 1, then you can see that that atom gets the positive charge. That means it has donated 1 electron, and the proton which is present, it is very high in number, and it gets the positive charge. So this positive charge is like, since it gets the positive charge, then you can see that the charge of that atom will be positive. Then if it takes 1 electron, then you could see that 1 electron would be more in number, so this atom gets the negative charge. So if you can say that this has the negative charge, so this atom has the negative charge. So if an atom has the positive charge, then we say that cation. So we say that it is the cation. If an atom has a negative charge, then we say that the anion. Now question comes like how to remember this cation and anion very easily. So many a times if we write many atoms, like if we write Na plus, we write then Cl minus. So if there's a confusion thing, suddenly if somebody asks, then what is in this, which is cation, which is anion. So we get confused and we say sometimes as wrong answer. So what you need to do, if it is positive, you remember that there is cation, so it has the positive symbol. So this T, if you remember, then you can easily say if it is positive, it is cation. So in cation we have T which resembles same like plus symbol. Then you can say easily any atom is given. If it is plus, then you can say cation. If it is negative, you can easily say anion. So this would be like easy remembrance. So you can, if you have understood, please try to follow this such that there won't be any confusion. Like if it is positive, so if you take any plus example, since it is positive, you can say that it donates the atom. So we have even seen how this formation. So it has electronic configuration of 2, 8 and 1. Then chlorine has an electronic configuration of 2, 8 and 7. So since this tries to donate this becomes positive and it takes 1 electron, so it becomes negative. So we have seen all this formation. So if it is positive, then it is cation. How to remember? This is the positive symbol which is present in cation. So this is about the ions. So I hope this topic or what is this ion topic is clear for you all. Next is the valency. Valency one topic. So what is this valency? So valency is the combining capacity or the combining power of an element. So if they say like this, suddenly we don't understand. So we can even say that how much the element has the capacity to react with other element. So you can say that valency is nothing but the reactivity capability of an element with the other element. How much those two atoms they try to react each other, then they form the compound. So two elements, how much they have the reactive capability, that is called as the valency. So in simple words, it is like reactive capability of the element with that such that it reacts with the other element. So reacting ability is nothing but the valency. So valency can be used to find out how the atoms of an element they combine with other atoms to form the chemical compound. So with the help of the valency, we can easily say that the combining capacity of this atom is this much and it has the valency of this much such that it has formed the chemical compound. So you can see that one example which has I have said that it has a Valency of 4. The combined capacity of this carbon is 4. So what is this? Is this carbon, this valency is 4. So this is called as valency. So this was about the valency. So you can find out how the atoms of an element will combine with other atoms such that they form the new chemical compound. So this was about the valency. Next we will see how to write the chemical formula. So writing of the chemical formula. So there is a one table which is given in your textbook which is very important. So you need to remember that such that you can easily write this chemical formula of any of the compound. So names and symbols of some of the ions they have given, like page table number 3.6, page number 37. So we will try to directly solve this with an examples. So we'll see different examples to solve this, and we'll understand how to write the chemical formula. So first one, if you take as example of calcium carbonate. So from that table, if you look, so calcium, it has the symbol as Ca2 plus. Then carbonate, if you see, then it has CO3 2 minus. So how to write the chemical formula of this compound is now question. So what you need to do is just you bring this to this side and bring this to this side. So write this 2, then 2. So you can write now as Ca2 CO3 twice. So you will see that it has two same things or which has the divisibility factor. So you can see that the chemical formula will always be written in the simplest form. So you can try to divide this. So what will be the formula of this compound of calcium carbonate? Then we write it as simple CaCO3. So this was one thing how to write the chemical formula of this compound. Next example, if you take as then magnesium hydro, that is, if you take example of magnesium hydroxide. So from that table, so if you take magnesium, then it has, where is magnesium? It has Mg2 plus, then hydroxide, then it has OH minus. So just simple minus means -1. So just bring this to this -1 as this side and 2 this side. So the question comes, what does this symbols minus and 2 plus indicates? So they only indicate the charge which is present on that atom of that element. So no need to bother about the charges. So only the numbers you need to take. Only you need to consider this numbers. So what happens here is how to write. So Mg. Then if you take OH, then you can see that this whole is one molecule. OH is combined B, so which has 2. So you need to write it as for both. So if you write OH2, then it indicates that this 2 is only for H, that is hydrogen. But it is not so. It is for both. OH twice is for both. So how to pronounce it? MgOH twice. So we'll see. Say this as MgOH twice. So I hope this chemical both examples are. Some more examples. So we have seen calcium carbonate, then we have seen magnesium hydroxide. Then there are different examples. So try by yourself some of them also you can try. Then we have magnesium fluoride. So if you remember that table, then you can write it very easily. Magnesium fluoride. So just now we have written for magnesium which has Mg2 plus. Then if you take chloride, where is chloride? Chloride, here it is Cl minus. So if it is minus, that means -1. So just bring this here, then this here. So right here 2, here 1. So what will be this? MgCl2. Since this is Cl2, there is one atom. So with this there are no different atoms. So you can write it two directly. If it is two atoms or two molecules combined, then you can say that it has. If we have seen NgOH twice, so this two is for both OH molecule. But here it has only one, so we have written NgCl2. Then we have ammonium sulfate. So if you take ammonium sulfate, which has NH, ammonium sulfate, if you take ammonium and sulfate, if you take, it has NH4 does. And if you take sulfate in that table, they have given SO4 2 minus. SO4 2 minus. So if it is plus, that means it is plus 1. So just bring this here and here. So here it is 1 and here it is 2. So here this 2 is nothing but it is for both of you. So you need to write it as NH4 twice SO4. So this is how we write ammonium sulfate. NH4 twice SO4. So this was about ammonium sulfate. So next example, if you take, it is like calcium oxide. If you take example of calcium oxide, so calcium, we have written from that table. So if you take calcium, it has Ca2 plus, then it has oxide. If you take, then it is O2 minus. So just bring to this side, this to this side. So you can write it as I write it here, Ca2O2. So it has the same divisibility, or it can be written in simplest form. So if we divide it both, then we write simple as CaO, that is calcium oxide. So these were the methods to write the chemical formula of any compound. So have been clear with writing the chemical formula. Now we will see what is this molecular mass. So I hope it is clear for you all today's class. This will be very important, like atomic mass, how to calculate, wherein you need to remember the atomic masses. So next is the molecular mass. So what is this molecular mass? So we say that the molecular mass of water, that is H2O, is 18. So how do we say that it is 18U or 18AMU? So we say that it is 18U. So how to calculate this molecular mass? So we'll see that. So to calculate this, one should know the atomic masses of each element. So we need to know hydrogen atomic mass separately, oxygen atomic mass separately. So what are the hydrogen? So hydrogen atomic mass is 1. Then it has 2 hydrogen atoms. So we try to multiply. Then you can see that it has atomic mass of oxygen, which is 60. So when we combine or when we add, we get 18U. So this is how we calculate the molecular mass. Next is HNO3. So we say or we calculate this. So HNO3, if you try, it has 1 ammonium, which has the atomic mass of nitrogen is 14. Then oxygen, which has 16 as its atomic mass, and it has 3 atoms. So we multiply it. Then if we add, then we get something like 63U. So this is about the molecular mass. So this is how to define now the molecular mass. So molecular mass is the molecular mass of the substance is the sum of the atomic masses of all the atoms in that molecule of a substance. So it is the sum of all the atomic masses of the element of that substance. So sum of the atomic masses of all the atoms in the molecule of that substance. So if you take this, then water, it has the molecular mass of 18U. So how to define? The molecular mass of a substance is the sum of the atomic masses of all the atoms in any molecule of the substance, in a molecule of a substance. So, is it clear for you all, the molecular mass? So, let me define it for the final time. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. So, this was about the molecular mass. So, in tomorrow's class, we will see mole concept. So, that is the last part, and which is very important, and where the students will get confused, or it will be like confusing one. So please don't miss the tomorrow's chapter. So tomorrow's class, which is the functional unit form mass. So some of the functional unit compounds which are present, then we say how to calculate that functional unit mass of that compound will be seen. Then we will see mole concept. So which is very important, at the same time it is very confusion. So please be present in tomorrow's class such that you people don't have any of the doubts. So I hope in today's class whatever we have learned is clear for you all. That is, we have learned about atomic mass, then we have learned about molecules, then we have learned about ions, how we say the charge of that molecule of that ion, like if it donates, it is cation, it gets positive. If it receives, it gets 1 electron, so it is called as anion. And we have learned the trick to remember this cation and anion. Then we have seen the molecular mass. So before that, we have seen the writing the chemical formula. So how to write the chemical formula of a compound we have seen. Then we have seen the molecular mass, for which to find out the molecular mass, we need to know the atomic mass of the elements that are present in that compound of that substance. So we need to know the atomic mass, so which is very important. So in tomorrow's class, we will see functional unit mass. So today, for today's class, we will wind up here, and we will meet tomorrow for the further chapters. So I hope in today's class it is very clear. So please tell me if I am going too fast, or if you don't understand the class, please do say me, such that I'll repeat those topics for you all once again if you are not clear. Or sometimes if I go very fast in some topics, please do say.